Okay, let us now discuss question number 24 from the practice sheet. Question number 24 says, a vertical tower stands on a horizontal plane and is surmounted by a vertical flagstaff of height h. At a point on the plane, the angles of elevation of the bottom and the top of the flagstaff are alpha and beta respectively. Prove that the height of the tower is h times tan alpha upon tan beta minus tan alpha. So what the question says is, let us try to draw the diagram of this question. Question number 24. Let us read it line by line. It says a vertical tower stands on a horizontal plane. So for the first, to initiate the diagram, let us first draw a horizontal plane. So let us say this is a horizontal plane. Now on this horizontal plane, let us draw a tower. Let us draw a vertical tower on this plane. Let us say this is the vertical tower. I am considering the tower, the line of the tower as this line. Let us say this is the, if I want to draw the line diagram of this tower, I can consider this as the line of tower. This point is, let us say, A, and this point is B. So this is the vertical tower. Further it says this vertical tower is surmounted by a vertical flagstaff of height h. So on this tower there is a vertical flagstaff of height h. It means the vertical flagstaff is something like this. This is the vertical flagstaff. Let us say this is C point. So AC represents the vertical flagstaff. So what conclusion can we draw from this diagram? That the top of the tower and the foot of the flagstaff are same. Okay, that is A point. They are coinciding. Okay. So now, and it is given that the height of this tower is h units. Further it says at a point on the plane means on this plane, the angles of elevation of the bottom and the top of the flagstaff. So from a point on the plane, let us say this is a point D. From this point, if I observe the flagstaff, I can see that this is the bottom of the flagstaff and this is the top of the flagstaff. So to observe the bottom of the flagstaff, it says the angle of elevation is alpha, and the bottom and the top of the flagstaff, it says the angle of elevation is beta. It means if I want to observe this this bottom of this flagstaff or the top of this tower, I need to move my head alpha degree upwards. Okay. So what does this mean is, if I say that this is the line of sight of this bottom, if this is the line of sight of this bottom of the flagstaff, I can say that this angle represents alpha. Okay. Similarly, if I want to observe the top of the tower, this is the line of sight of the top of the tower, like this. This is the line of sight of the top of the tower, top of the flagstaff, and it says to observe this top of the flagstaff, I need to move my head a beta degree upwards. So that's why it is the angle of elevation. So this angle is beta. It is given that this angle is beta. And further, we need to prove that the height of the tower. What is the height of the tower? In the diagram, I can see AB represents the height of the tower. So it says, prove that height of the tower is h times tan alpha upon tan beta minus tan alpha. So it means to prove, what we need to prove is, we need to prove that AB, which is the height of the tower, is equals to h times tan alpha upon tan beta minus tan alpha, okay, upon tan beta minus tan alpha. This is what this diagram represents and what the question asks. Okay, so we have understood the question, we have drawn the diagram as well, and our task is to prove this, or our task is to determine the height of the tower in terms of h, alpha and beta. Okay, so what should be our next step? Our next step should be to identify the right angled triangles in this diagram. I can see that clearly there are two triangles visible in this diagram. One triangle is ABD. Okay, one triangle is ABD. And what is the another triangle? Another triangle is CBD. So the second triangle that is visible in this diagram is triangle CBD. So these are the two triangles that I can observe in this diagram. Now we need to determine tan alpha and tan beta, okay, because our proof requires us to determine the value of tan alpha. It has tan alpha, nothing sin alpha, not cos alpha, only tan alpha. So if I talk about alpha, alpha lies in the triangle ABD. So with respect to this angle alpha, I can see AB represents the perpendicular or the height or the side opposite to angle alpha. And similarly, this BD represents, it represents the base with respect to this angle alpha. Okay, and I can also see that this BD is a common side between the two triangles, between both the triangles ABD and CBD. So you can see this is a common side. So in this triangle, if I write the value of tan alpha will be AB upon BD. Okay, the value of tan alpha will be AB upon BD. Now further, let us observe the second triangle. In second triangle CBD, with respect to this beta angle, I can see CB represents the height of the tower, okay, the height of the triangle or the perpendicular or the side opposite to angle beta. And further, this BD represents the base of the triangle. So here also I can write the tan ratio, that is tan beta is equals to BC upon BD. But please observe what is BC. I can write BC is basically AC plus AB. And what is AC? AC is the height of the flagstaff, and height of the flagstaff is given as H plus AB. So what I can write is tan beta is equals to, in place of BC I can write H plus AB upon BD. So what I get from this? I get the value of BD as H plus AB upon tan beta. This is the value of BD. Okay. Now observe this condition. From this condition I can write the value of BD is equals to AB upon tan alpha. Okay, this is AB upon tan alpha. So what I can observe is, if I assume that this is the first equation and if I assume that this is the second equation, I can see both the equations contain BD in LHS. Therefore I can equate both the two equations. So what I will get is, by equating or by comparing equation 1 and 2, I will get AB upon tan alpha is equals to H plus AB upon tan beta. Okay. Now further, let us cross multiply this. Tan beta will be multiplied here and tan alpha will be multiplied here. So like this we will go for cross multiplication. AB times tan beta is equals to H tan alpha plus this will give you AB tan alpha. Okay. So from here I can shift this AB tan alpha from RHS to LHS, and I will get AB times tan beta minus tan alpha is equals to H times tan alpha. This is what the condition is. Then further I can shift this tan beta minus tan alpha in RHS. So the value of AB will become H tan alpha divided by tan beta minus tan alpha, and this is the condition which is required, which is to be proved. AB represents the height of the tower, and we have got this condition. Okay. So this is how you need to solve question number 24. You can see this question is not difficult. It is just based on the concept that we have understood previously. What I told you, draw the diagram, determine the right angle triangles, determine the relation between the right angle triangles, and just you will get the condition. Okay. If you initiate the question, if you draw the diagram, if you identify the triangles, you will automatically get to know how to solve this question. Okay. So this is the solution for question number 24. We have completed question number 24. Okay, so first you note this, then we will continue. Okay, let us now discuss question number 25 from the practice sheet. Question number 25 says a ladder rests against a vertical wall at an inclination alpha to the horizontal. Its foot is pulled away from the wall through a distance p, so that its upper end slides a distance q down the wall, and then the ladder makes an angle beta with the horizontal. Show that p by q is equals to cos beta minus cos alpha divided by sin alpha minus sin beta. Okay, so let us try to understand the question. It says that there is a ladder which rests against a wall. So how a ladder rests against a wall? First, there should be a horizontal plane, okay, and on this horizontal plane there is a vertical wall like this. This is a vertical wall, and the ladder rests against this vertical wall like this, okay, because it clearly says that the ladder rests against a vertical wall at an inclination to the horizontal. It means if ladder is like this, it rests like this with this vertical wall, it will make an angle alpha with the horizontal. The inclination of this ladder with horizontal is alpha. So it means, so this is question number 25. So if I try to draw the ladder is something like this. Okay, the ladder is something like this. Let us say AB represents the ladder. AB represents the ladder. This ladder is resting against this wall and it makes an angle alpha with this horizontal. Okay. Now, what further it says, if this is the ladder, its foot is pulled away from the wall. Okay, its foot. What is the foot of the ladder? This B represents the foot of the ladder. What happens is, I pulled the foot of this ladder, okay, through a distance P, okay, away from the wall. It means, now this is the foot, I can shift this foot, I can pull this foot, or I can push this foot towards the wall, or I can pull it away from the wall. So what it says, you need to pull it away from the wall. So what happens, this B point shift in backward direction, okay, and it says its foot is pulled away from the wall through a distance of P, okay, P units distance से हमने इस foot को पीछे की तरफ खींचा है. So if this foot is pulled away, what will happen? This top of this ladder or the head of this ladder will come down, it will slide down because the length of the ladder is fixed. Okay, the length of the ladder is fixed. That's why if I pull this foot away from the ladder, away from this wall, this top or the head will automatically come down. So if this is the ladder, it will shift like this. Okay, it will be pulled like this. So what will happen? When I pull this wall, this ladder, through a distance of p units, from this position. The new position of the ladder will be, let us say the new position of this ladder is CD. Okay. So CD represents the new position of the ladder. Now what about the CD? I will say that AB is equal to CD. Why? Because this is the length of ladder. Because this length will not change. If I pull away this foot, the length of the ladder will not change. It's obvious. Okay, I am not stretching the ladder, I am just pulling the foot of this ladder away. So this top will slide down. What it says is, if you pull the foot of this ladder by a distance of p units like this, then its upper end, this end, slides down a distance q units. So it means the gap between this upper position, or the distance by which this A point slides down, is q units. Okay. So this AC length is q units. Now further, and then the ladder makes an angle beta with the horizontal. So the new angle that this ladder will make with this horizontal is this one. Let us mark it here. I mark it like this. This is the new angle and this angle is beta. Beta is the new angle that this ladder makes with the horizontal. Okay. Further it says, show that P upon Q is equals to cos beta minus cos alpha upon sin alpha minus sin beta. So now we have drawn the diagram, and what our task is? Our task is to prove that P upon Q is equals to cos beta minus cos alpha upon sin alpha minus sin beta. This is what we need to prove. Now, so we have written the proof also. What we need to prove is, then further I can analyze this equation, and I can see that this particular equation contains cos beta, cos alpha, sin beta and sin alpha, and P and Q. So our task will be how to relate cos alpha, cos beta, sin alpha, sin beta, and this P and this P and this Q. Okay. So if I identify the triangles in this particular diagram, then I will be look about how to determine the value of cos alpha or sin alpha or cos beta or sin beta. This should be the approach to solve this question. Do I require to determine the value of tan alpha or tan beta? No, obviously not. Why? Because it clearly says this relation has alpha, this relation has cosine ratio and the sine ratio. Okay. So let us try to identify the triangles in this question. Our next task is to determine the triangles in this diagram. I can clearly see there are two right angled triangles that can be observed. The first right angle triangle is triangle this A, this B, and let us mark this position as E. Okay. So A, B and E is one right angled triangle, A, B, E. Then what is the second right angle triangle? You can see this C, this D and this E. So second right angle triangle is triangle C, D, E. So we have two right angled triangles. Now in triangle ABE, I can see alpha is the angle. Okay, and alpha is also available in the equation that we need to prove. So I need to focus on this triangle. I can see with respect to this alpha angle, this AE represents the perpendicular or the height or the side opposite to this angle, and this BE represents the base, and AB represents the length of the ladder, which is the hypotenuse of this particular triangle. Okay, I am repeating it again. In triangle ABE, if you observe ABE, this angle is 90 degree. Okay, this with respect to this alpha angle, I can say AE represents the perpendicular, BE represents the base, and AB represents the hypotenuse. So in this particular triangle, what ratio should I calculate? What trigonometric ratio should I calculate? Should I calculate tan alpha? Should I calculate cos alpha? Should I calculate sin alpha or cosec alpha or sec alpha or cot alpha? I should calculate only those ratios which are available in the proof, okay, which are available in this equation. I can see cos alpha is available as well as sin alpha is available. So in this particular triangle, I will calculate the value of cos alpha and sin alpha only. Okay. So what is the value of cos alpha? In this triangle, cos of alpha, cosine of this alpha angle will be, this is alpha, cos alpha is base upon hypotenuse, and this BE represents the base and AB represents the hypotenuse. So cos alpha will be BE upon hypotenuse is AB. Okay, this BE and this AB. Further, what is sin alpha? In this particular triangle, sin alpha will be perpendicular upon hypotenuse. What is perpendicular? Perpendicular is AE, okay, and hypotenuse is AB. So perpendicular is AE upon hypotenuse is AB. This is what I can determine. Now further, we have determined the two trigonometric ratio in this triangle. Now the other two trigonometric ratio left are sin beta and cos beta. So in which triangle beta angle lies? I can see beta lies in triangle CDE. This is triangle CDE. In this triangle, with respect to this beta angle, this CE represents the perpendicular and this DE represents the base and this CD represents the length or the hypotenuse. Okay. So in the second triangle, I can determine the value of cos beta. Cos beta will be equals to base upon hypotenuse. What is the base? This DE represents the base. Okay. So this DE, I can write this DE upon CD. Okay, that is base upon hypotenuse. But I can see that AB and CD are equal. So in place of CD, can I write AB? Yes, I can write it. So this will be DE upon AB. Okay, DE upon AB. Now, then next is we have beta. Our next task is to determine the sin beta. What is sin beta? Sin beta is perpendicular upon hypotenuse. Perpendicular represents CE and hypotenuse is CD. So in this triangle, I can write sin of angle beta is equals to CE upon CD, or since CD and AB are equal, I can write this as CE upon AB. So we have four different equations, okay, four different trigonometric ratios. Now, how to solve this question, how to use these ratios? It's very simple. Just think, my task is to determine the value of cos beta minus cos alpha. So from these four equations, can I calculate the value of cos beta minus cos alpha? Yes, very easily. So if I write cos beta minus cos alpha, this will be equal to what? Cos beta minus cos alpha will be DE upon AB minus BE upon AB. This will be the value of cos beta minus cos alpha. So this will give you DE minus BE upon AB. Now what is DE minus BE? This length is DE and this length is BE. So if I subtract BE from this DE, I will get this, that is DB, and DB is P. So in place of DE minus BE, I can write it as DB upon AB, or I can write it as P upon AB. So ultimately the value of cos beta minus cos alpha is P upon AB. P upon AB. Now, so I have calculated the cos beta minus cos alpha. What is the next ratio, next value? It is sin alpha minus sin beta. So can I calculate sin alpha minus sin beta? Let us determine the value of sin alpha minus sin beta. Sin alpha is AE upon AB. This is AE upon AB minus sin beta. Sin alpha minus sin beta, it is CE upon AB. So this is equals to AE minus CE upon AB. Now what is AE minus CE? This length is AE, this length is CE. So CE is subtracted from this AE, you will be left with AC, which is Q. So in place of AE minus CE, I can write AC upon AB, which is equals to Q upon AB. Okay. So I have the value of sin alpha minus sin beta as well. So if I say that this is the first equation, this is the second equation. Now my task is to determine the value of cos beta minus cos alpha upon sin alpha minus sin beta. So what should I do? I will divide equation 1 and 2 to get the value of cos beta minus cos alpha upon sin alpha minus sin beta, and this will be equals to P upon AB upon Q upon AB, and this will give you P upon Q. Okay. So it implies cos beta minus cos alpha upon sin alpha minus sin beta is equals to P upon Q. So this is the condition that we need to determine. Okay. So what you can see is how I solved this question. I thought just that I need to determine this relation. It means somehow my task is to determine cos alpha, cos beta, sin alpha, sin beta. Then further, if I determine all the four ratios, my next task is to determine the value of this cos beta minus cos alpha, sin alpha minus sin beta, and after that I can see if I divide these two, I will get the final result. So that's why I divided these two equations and just obtained the final result. It is not at all difficult. You can see it's very simple method. Okay. So this is how you can solve this question, question number 25. It's very easy question. Just the difficulty, just the complexity is how to analyze this condition, how to approach, how to draw an approach from the given condition. This is the condition, that is the requirement. So you need to draw the approach from this requirement only. Okay. So this is the solution for question number 25th. First you note this, then we will continue.